Hi, I'm Miss Huang, and today's lessons due now is what is the order to classify rational numbers? So your hint is think of whole numbers, rational, integers, and natural numbers. So think of how you would classify them into sets and subsets. Think of Venn diagrams or circles within each other. So today's TEK is 8.2a. The lesson target is the scholar will extend previous knowledge of sets and subsets using a visual representation to describe relationships between sets of real numbers. And our DOL is given 4 problems. Scholars will extend previous knowledge of sets and subsets using a visual representation to describe relationships between sets of real numbers with 100% accuracy. Our TEK's breakdown is the visual representation of it all, so whether it's in Venn diagram form or in table form, so we have both. In this case, for rational numbers, integers, and whole numbers, we have them housed within circles within each other, so that's a form of a Venn diagram. And then real numbers with rational and irrational numbers are housed in a table. So the Venn diagram is inside the table representation of real numbers. And so with our understanding of the visual representation, we also have to understand the relationship of each category to each other and to our new category of real numbers. And then the correct answer for our do now was that rational numbers was our big category. So some examples of rational numbers are 27/4, 0.3 with a line on top, which just means that it's 0.3333. The 3 is repeating, -6/7, and 4.5. So rational numbers are usually fractions as well as decimals that are repeating or terminating. So terminating means to end. So decimals that end. Integers are a subset or a subcategory within rational numbers. So that means that integers are also rational numbers. And integers are positive, negative numbers as well as 0. So in this case, we have all negative numbers, -1, -3, -2, because the positive numbers and 0 are also considered whole numbers. So as you can see, we have 0, 3, 1, and the square root of 4 as an example. Because if we solve for the square root of 4, what number times itself is equal to 4? That's going to be 2. So 2 is a whole number. And examples of irrational numbers are square root of 17, square root of 2, negative square root of 11, and pi. And we'll go into the differences of irrational numbers a little bit later, but just as a preview, most times irrational numbers are square roots, and they don't include decimals that continue on forever, so that don't terminate or don't repeat. And lastly, they can't be written as fractions. Then we have an activity where you have to fill in the blank by matching the vocab words of real, irrational, integers, rational, counting / natural, irrational, and whole into these definitions. Then we have a practice. So we have to write each given number below into the correct set and subset. So our first number is 0. So 0 is a real number, it's a rational number, it's an integer, but its most specific category is going to be whole numbers. So we're going to put it into the whole number subset. 1, the same logic applies. It's a real number, it's a rational number, it's an integer, but its most specific category or subset is going to be whole number. The same thing for 3. So 3 is a whole, an integer, a rational, as well as a real number, and square root of 4. So we already went over this. Square root of 4 is a perfect square because 2 times 2, or 2 squared, is equal to 4. And 2 is a real number, it's a rational number, it's an integer, and its most specific category is a whole number. So when we're writing these numbers into the sets and subsets, the visual of a Venn diagram, we have to make sure that we're classifying the numbers in its most specific category. We have the number -1. -1 is not a whole number, it's an integer, which also makes it rational as well as real. Same thing for -3. Same thing for -2. And then 27/4 is a fraction. So remember that rational numbers are fractions. Our next number is 0.333, and so that's a repeating decimal, and repeating decimals are rational numbers. So I'm going to write that in the rational numbers subset. And so instead of writing all the threes, I'm just going to write a line on top because in math, we use that notation to show that that number is repeating. And so that means that 0.333 is a rational number and a real number. Then we have -6/7. And so fractions, positive and negative, are rational numbers. So we're going to put that in the rational numbers subset. And that also means that -6/7 is a real number. We have square root of 17. So if we solve for the square root of 17, it's not a perfect square. So it's actually going to be an irrational number. Same logic for the square root of 2, as well as negative square root 11. And lastly, pi. So all these irrational numbers are also real numbers, but they're not rational numbers. This next activity is a you do. So it's a similar activity with just different numbers. Then for this I do, write all names that apply to each number. Then place the numbers in the correct location on the Venn diagram. So we have 3.5. 3.5 is a mixed number, which is a type of fraction. So that's going to be a rational number and a real number. Then we have square root of 7. So we know that's not a perfect square because no whole number times itself is equal to 7. So this is going to be an irrational number and a real number. Then we have 5/4, which is a fraction. So it's going to be a rational number and a real number. Then we have 1, which is a whole number. It's also an integer. It's also rational. And lastly, it's real. 2.6 is a decimal, so it's going to be a rational number as well as a real number. And then square root of 9, that's a perfect square. We have to think of what number times itself is equal to 9. That's 3. So 3 is a whole number. It's also an integer. It's also rational. And it's also real. The next activity is for you to do the same thing. So you're going to draw on the slide and classify each number and then write it into its correct subset. We have another one, and now we have a poll. So you have to answer whether a whole number is considered a rational number. The second poll is a rational number an integer? And then you have to do a short write. So the question is, what is the difference between a rational number and an irrational number? So this activity is you have to write out what did you learn today about classifying numbers, and you can write about what is still confusing you. And lastly, your DOL. So click on this link right here for your DOL Google form. Thank you so much for following along today's lesson, and see you in the next math video.